I only planned for about 50 minutes, so yeah, we have a little bit of slack time, but I don't want to go right up against the hour either, so
Yeah, we'll get started in
yeah.
another minute.
Okay.
With whatever we can do.
Let's just start, I guess.
All right, everyone, welcome to the May KWSQA meeting. My name is Tina Fletcher, and I'm your KWSQA president. This is our last regular meeting before we take a break for the summer and for our conference targeting quality. But we will have a social event in June as usual. The details for that, we'll send them out soon, maybe because we haven't picked a place yet. If you have any recommendations, let us know. The big announcement about the conference this week is that we now have all of the speakers and topics confirmed for day 2 of the conference. So those are now available on our website. So I know last month I said that it was the best time to buy tickets for targeted quality because of the early bird rate. But now this is really the best time to buy because not only can you get the early bird rate, but you also can see all the speakers and talks before you buy. If your company is looking for a way to get involved with the KWSQA, we have a couple of options for you there as well. We're currently looking for a company who wants to work with us for another testing games event, probably to take place sometime in the fall. There's also some spots left for sponsorship for targeted quality too. So feel free to come up and chat after or get in touch over email if you're interested in any of these things. So I'll introduce our speaker for today. We've got Manchur here. I see a number of faces out there actually who probably already know Lee and have worked with him in the past from the days where he was at BlackBerry. But for the most recent 4 years, Lee has been at the Ontario College Application Service, or OCAS, where he's been the manager of QA. When not at work, you might find Lee watching his beloved Winnipeg Blue Bombers. That's a CFL team if you didn't know. Or maybe playing around with golf, or cooking something delicious on his big green egg. Today, Lee's going to tell us about some important lessons he's learned in his test automation journey, and I will let him take it away from here.
Thank you, Tina. Before I get to actually this presentation, I wanted to use this group as a focus group for a possible next presentation and see if it will work. The title of it, if it goes, would be Everything I Don't Know, or Everything I Shouldn't Know About Software Testing I Learned from a Test Consulting Agency. So this comes from my manager. We often get, I'm sure a lot of you too, get emails from test consulting agencies with radical promises. So this email came to my boss, something like this today, and this was too good to pass up, so I had to include it in this presentation last minute. These are all the services this test agency offers. So I had a look at their website. It looks like a pretty professional looking website, a pretty slick name, Bug Raptors. Okay, so I went to their About page. A couple of things popped out at me that was a little strange. Any red flags for any of you here today? Yeah, 0% and yeah, 100% client satisfaction. I'm not satisfied with their grammar. And yeah, 0% defect leakage. So I wondered if they applied their 0% leakage methodologies to their own website. So I scrolled down this page a little bit more, and I noticed something here that formatting of that address doesn't really follow conventional mail label formatting with the state on a different line than the city. Emeryville's in California, home of Pixar, Leapfrog. I have contacted some companies down in the valley, and this area code did not look familiar to me. So I opened up another tab, And I found that that area code's in Maryland. That doesn't seem to make sense to me. I'm, again, not satisfied. So then I scrolled down a little bit more and looked at the footer. Anything look strange about the footer? California has moved. It is now in the Northwest Territories. Or maybe Maryland moved, I don't know. And also that push icon right there is cut off. And this kind of bugs me. It's a bug. So maybe they just don't apply their methodologies to their own products. Okay, so maybe because I get dozens of these every month. I feel like I could put together a full presentation about it. But today we're talking about what I learned about test automation from a developer. So Tina said a few things about my personal life. We were friends. We go back 13 years when we were naive interns in this industry. And now we're grizzled or disgruntled veterans. And I know several KWSQA board members as well. For the last number of years, worked with them in some degrees. And I thought we were all kind of friends, at least a little bit. And then they put me as the follow-up act to last month's presentation from a NASA JPL scientist. So maybe we're not so good friends, because that's a pretty tough act to follow, but I'll do my best. So I'm sorry to disappoint anyone that was here last month. I'm not a NASA scientist, unfortunately. But I did have our graphic designer at OCAS whip up this with our beautiful OCAS logo, rising above a planet, maybe Earth, maybe not. So this is as close, unfortunately, this is as close as we'll get to outer space today. So there's two parts of my talk. One, a little bit about teamwork and where the idea for this presentation came from, and another about some technical coding aspects. We'll get into some code. We code in C#.NET. And so that's what all the code examples are based on, but the underlying principles should be applicable to many languages, regardless of what language you use to develop test code. But we do have some ground rules for this presentation first. There's one overriding one. I'm very sensitive to the topic of test automation, and there's pockets of the test that say test automation is not really testing. And I'd like to set those theoretical arguments aside for today. We're in this room, hopefully you want to learn something about automating tests, regardless of what your stance on that is. And there are good reasons to automate tests and not so good reasons to automate tests. And there are good things to automate and not so good things to automate as well. But I don't really want to talk much about that, other than I don't want to be seen as a coding or test automation junkie. Because what we should at our company automate is something that I think about, if not every day, then every week. And I want to make sure that we're doing the right thing in the right place. But I'm not going to get into those kind of theoretical discussions today, because I think it is specific to whatever line of software you're testing. But a particular topic in test automation that's often put on trial is automating front-end tests. And to be totally transparent, we actually do a lot of that at OCAS, and we do think it is valuable for what we do for our applications. In part because we view some of the concepts I'm going to talk about to decrease some of the code maintenance that typically creates pitfalls for automated UI testing. But I'm also going to talk about UI tests as well, because it's just an easier concept to explain in a forum like this. And again, hopefully the underlying principles, even if you don't automate front-end tests, are applicable to other types of tests you might automate. The overriding concept for this presentation is these, count them, 4 words. Test development is development. And as I said in the abstract for the presentation, oftentimes testers don't automate for many years. I didn't do any coding for a very long time between or across several different jobs that I had. But then we're thrown into a role, especially a company like mine, where we have a relatively small testing team, and we think as a company it might be good to automate some of this test to speed up regression test cycles. But if we tried at first to hack away and develop some test scripts, but if you're not actually developing every day, it can be really hard, and pretty quickly, even if you find easy ways to do it, you can find yourself in a maintenance nightmare. So I came to this realization at some point about 8 years ago, when I started a job here, and then I moved all the way down there to work with the test team and develop their skills, work on interesting applications, and and also partner with our development team to make sure our test and dev teams were coordinating and operating effectively. So there are two things I realized when I got down south. One, for some strange reason, everyone was in a really great mood going to an office like this and looking out our windows at the tops of palm trees and spending weekends in places like this. Everyone was in a really great mood. I couldn't quite figure out why. But number two, I was there to help partner with our dev team. And I know some people here have worked with some people I worked with down there, and they're all great people. But what I found is that it was actually hard, even though everyone had good intentions, in part because our office was set up kind of like this. This wasn't our actual floor plan. But the main idea is we had our dev team up here at least we were all on the same floor. And then our test team way down here. And what I discovered is that even though I moved 2,400 kilometers to help build this relationship and partner with our development team, real change didn't actually happen until we closed that last 200-foot gap. And then we sat right beside them, not to shout at them as we were finding bugs, but I think there's just something with face-to-face communication. And for those of you who know me, I'm not always the most outwardly social person. So maybe this says more about me and the fact that I couldn't really do that until I moved that last 200 feet. I couldn't walk that distance several times over the course of the day, but when your teams are just forced to cohabitate, I find that some of the problems like the ones we encountered, that I'm going to talk about it in a few minutes, you can get resolutions to them much, much quicker. And I found that as well at OCAS too, where until 6 months ago, maybe it was about 8 months ago now, we had a pretty open concept office where we were all in cubicles, and but there was no cubicle walls, so you could see halfway across the building really if you wanted to. But how we were set up is we had a row of testers, and then like a 10-foot aisle, and then a row of developers. And certainly you can get kind of the cohesive dev QA team relationship going when you work like that. But 6 months ago, for a variety of reasons, we changed and we just had these long tables. And how we set it up is we put the testers in the middle, and then 360 degrees around, we surrounded them with developers. And even going from a 10-foot gap to kind of a totally immersive work experience, I think really helped things, because me and my counterpart on the development side, the development manager, were separated from the people who are actually developing the code and doing the testing. But sometimes I sit back and I see just someone turn their chair 180 degrees, and there's just an instant conversation that happens that, even though we have great tools like Slack, it's just easier to do when you work like that. So, if you're not even currently doing test automation, I would just encourage you, use your influence, whatever it may be, to get to that kind of working environment, because I've seen it in several situations now, and in different companies where it's just made things operate that much more smoothly. And the rest of this presentation wouldn't happen if I didn't myself turn my chair around and ask my development manager, hey, can you have a look at this test code? And so when I asked that question, he found a bunch of different areas to optimize. So this is kind of the roadmap for the rest of the presentation. I'll show this a few more times throughout as we move through these topics. But as a launch pad into some of the more technical concepts, I'm going to talk about Selenium UI tests, hold any criticism of that. And as I said in kind of the paragraph about this presentation, this is not yet another page object design, but as the previous slide said, it's more like page objects on steroids. So this is kind of a traditional look, if you're not familiar with how a very high level page object design work for, say, a random application with a login page and like a home page landing page. And basically you have a separation of concepts between the pages and the functionality contained in those pages and the tests themselves, so that if the functionality of those pages changes or something intricate to how those pages operate to even do the same functions, your tests don't have to change, because you're probably going to have way more tests than you will pages. And again, I'm very sensitive about the UI testing concept. So say if you wanted to test APIs and write some sort of integration test, you could just swap out a page with like an API definition with a route and the standard headers for that API and the data model for that API, and have a separation of service call definitions from your tests. So you could apply a similar concept in other ways. And so we did this too, and we thought it made sense. And so I whipped up what this looks like. That's what it looks like in an actual test. So you can see like a reference to the page, and then a login page, and say then this is an email application, say there's an inbox page that's next, and so on. And so over the next several slides, I'm going to show some changes that we made to this concept, where you can find like tons of articles on the internet about how to design a test suite like this. But after the changes are made, this is what the test looks like. It's actually almost the same. But what has changed is underneath. And so we'll get to that right now. The problem with the page object design that there's so many courses about online is actually the pages. That is the problem with the page object design. So this is a very simple application with a login page, compose email page, and an add contact page. And you can see, again, all the functionality is separated and this is between the pages. And this is textbook, pretty textbook things. And so I implemented this for one of our web applications like 3 or 4 years ago. And I asked our development manager, could you have a look at this, tell me what you think? And he had a look at it and took a few minutes and clicked around my solution. And he said, okay, Lee, it's terrible. And I said, why is it terrible? I have my pages. They're functionally separated. There's like no repeated code. Like, I got my username and password on one page and 2 in subject on the other, and so on. And I said, what's wrong? And he said, well, the problem is like this thing. What is that? And I'm like, that's the Selenium WebDriver. That's like the root of all evil in UI testing. It's persistent everywhere. You need it. You can't do anything without it. And so what's wrong with that? And he said, well, what if something new came along that replaced Selenium, and you wanted to use that instead? Now, in our real world, we have dozens of pages. You'd have to change this in dozens of places to update that and that and that and that. Oh, I'm going the wrong way here. And that and that and that and so on. And I'm like, Selenium's been around for like 10 years. Nothing's ever going to replace it, right? Nothing, ever. So I slept on it, and the next day I came back and I talked to someone on the development team, and he had a number of recommendations for me. But before I get to that, I want to go back to Computer Science 101. Does anyone know some of the 4 of the basic object-oriented design principles? If you want to just shout them out. Abstraction was one, yeah. Encapsulation, 2 for 2. Polymorphism, and yeah, right? I got a pretty good response. I don't know if I need to go over the definitions of all these, but they're up there, and I shortened it to fit on one slide. Obviously, they're more detailed than this. But so if we go back to the page object design model, which of those 4 principles does it actually implement? Yes, encapsulation, someone said. Any others? No. And that, was there another answer?
I was going to say, in theory, I think polymorphism does, but it doesn't use it.
Mm-hmm. How so in theory?
The null case is you don't use it at all, so all of those are polymorphism.
Right, okay. That's pretty meta, but yes. And because it's only using encapsulation, you actually do have a lot of repeated code. All of these, line by line, this is, when it comes to tester developing this, it's a bunch of grunt work. Repeating, the only thing that's changing is the IDs by which you identify things. And that's really the problem with page object design as it's usually presented. And there are some efficiencies with page factory, but they really don't solve this problem because ultimately you're still relying on Selenium and web elements that Selenium defines as Selenium defines them. And you're relying on all their methods directly. And some of the page factory tutorials out there make it even worse than this way. And so the main principle other than test development is that good developers, at least the good developers at OCAS, don't repeat code ever. ever. And to an untrained eye, like a tester, and certainly myself back several years ago, this was not repeated code, but in fact it is because of these rectangles that I've highlighted. And so if we applied traditional page up design to more of a actual development philosophy, what a developer would do if they're writing this application, the actual code for the application rather than the test is, they would create like a component library, and then they would instantiate versions of the component on various pages and assign them specific properties, rather than defining from the ground up those elements as this page object model does. And so if we applied that concept, we would get an architecture kind of like this, where we still have our tests, we still have our pages, but then we have this component library, and as I mentioned earlier, we would have a layer of abstraction on the driver as well, and wrap that into our own interface, and such that if we truly wanted to replace Selenium with Puppeteer or something else, we would do it there and nowhere else. You could apply this to other kinds of testing too, just for anyone falling asleep because I'm talking about UI testing. And you could apply it in other situations too. So this is what our model looks like. And description of this presentation, I talked about a lot of time savings. This is where a lot of our time savings comes in, because we're not redefining the same components over and over and over again. We start with a base class for a component. Rather than starting at pages, we would start with a component. We define a reference to the driver. It could be the Selenium driver, or it could be our own custom wrapper of it. And then find a way to identify a component. And that's really it. That would be common to every single component on every single web page or mobile application ever. And then we build on that as a functionality. Maybe build another on top of it. Form elements, text box, check boxes, radio boxes, and so on. So if you want to interface, assign those things that are common. Also, and then we would do is taps into a password field or username field or so on. We code, and it is a little bit of code there. Name controls that might have their own properties, or you might want to use polymorphism to override some of the methods as well, even different from text control, even though an email control is a type of text control. So we built up this component library, and then now I ask you how much Selenium code is in here. Kind of limited to here, but even then, if we've abstracted the web driver to our own custom interface, then there's actually zero code in here for zero Selenium code. Okay, now we need to work on the pages. How do we use these components to build up models of our application's pages? Again, start with some sort of base class that would define elements common to every page. In this case, we're just going to be base starter, every page. We could have defined additional properties like that. Compose email page and all different kinds of forms. They may have varying numbers of fields and various different types of fields, but they're all essentially forms. And so why don't we create a definition of a form rather than defining, 3 different types of forms? And so every form is going to have, a save button. On the login page, it might be called something different. It's doing the same action as a send email button on a compose email page, where it's doing kind of a submit and send action. And then there's going to be a list of fields. There could be any number of them. It doesn't really matter what they are, but there's some number where we're using this form. And then the page to add elements to the list. A way to fill it out. In this case, it's using the properties to find an interface for form elements to only look at required fields. Every field. But this is a much more programmatic way to define your pages than to grant out defining every single control over and over again and then how to use them within each page definition. And finally, the actual page. I'm just going to show one. I showed 3 earlier, but using this model, what a page would look like would be in the constructor initializing all the elements. And so there's going to be that username field and a password field. And we're going to use that method there to add it to the list of such form elements on this page, define only here where to identify it and any other properties we might want to define about that control. And we'll do the same for password. And then we'll define that save button. The interface said we had to implement up here. And maybe there's some page that aren't defined in the interface, but that's fine. We can much code related to our drivers, even on the actual tool here. To really create our much more modular, thus much more maintainable. I mean, this here fill a form which is filling out a random account, which might be fine for this test. But I could still specify a custom one if I wanted to by going back here. I could still specify a custom email if I wanted to by using that method and giving it a specific string. But for a lot of tests, you want to just initialize a test to get to a certain point, and just in order to do that, you just have to fill out a bunch of data. It doesn't really matter what that data is, and so to do that, you could just use that fill out form method and so on. So again, if the tests are relatively similar, how we overcame the problem of repeated code, just writing very similar code over and over again, which led to low maintenance. We utilized really all the properties of object-oriented design. We virtually exterminated all duplicate code and also minimized our external library references. And so, maybe, this is a much better way if you decide to do page object design or to model your UIs and test, write automated tests on the front end. That's one way to do it. But even if you don't, if you're writing different kinds of automated tests, you can make, and you're using an object-oriented design principle in order to automate those tests. Really have a hard look or ask your developers, what layers of abstraction can I build into my test framework to increase my maintainability down the road. Okay, so a few more, a little quick, more quick discussions on the last 4 topics. The first one was overcoming a problem we had with repeated code, where it didn't, again, at first glance, it didn't really look repeated, but we're using kind of the same pattern, and the only difference was a utility method. And we found a place for this. This was in our test framework, and if you were, our UI test framework, if you were eagle-eyed, you may have spotted it in an earlier slide. So we'll go back and kind of refactor some of that code to get rid of the duplicate code. But just to talk about what delegate functions are, that's what they're called in C#. In other languages, they might be called anonymous functions or function pointers. And the basic pattern is this, where you have, say, a class where you want to pass in different methods. I guess I should say a delegate function is a function that can be passed as a parameter, just like you could pass an integer or a string or some other object type. Instead of that, you're passing in a function. And so there's an object with a bunch of methods. And one of them is, say, a delegate method or a function pointer. And it defines a return type and obviously gives it a name. And really, the advantage of delegate functions is that at compile time, the code doesn't need to know what that function is going to be. That's decided at runtime. At compile time, all that the code here knows is that it's some method that returns a string or returns whatever this return type is. That's all this object will know. And then when you have an application, or in our case a test, that wants to use a delegate function, it would initiate a new instance of that delegate type and pass in here a method reference. So this is actually some method that exists somewhere else. And at compile time, the only thing that's checked is that this actually returns a string. Or whatever this return type is. I keep saying string because that's how we used it in our framework. But this some method exists somewhere else. It could exist in an external library that you imported as a package from GitHub or something, or it could be some static class of utility functions that exist somewhere else in your framework. So how we use it here is with our text controls and email controls and the pages that use these controls. So this is what it looks like without the delegate in the text control. And then we'll refactor this to use that concept. So the first thing we did was over here, we need to define that initial reference that I stated on the previous slide. So we defined a delegate function that's going to return a string. And so this is a new type, and this type is going to be called create random value. Then we define an instance of that type, and we're going to give it a name called value command. And then in the set value here, because this is actually the repeated code, I should have stated that earlier. This is a repeated code we're trying to get rid of. Because it is 2 lines. It could actually be 1 line. But nevertheless, because of this couple lines of code here, I may have to create dozens of different kinds of text control subclasses for a whole bunch of different types of text boxes, like maybe a name text box or an email text box or a date text box and so on. And if all I want to do is have a different random data generator for each type of control, I don't need to define a whole bunch of classes for that. I can use this delegate design. Okay, so getting back to this. So I get rid of this code that's going to generate that random string. And I'm going to say just set the value using this value command, which is some method. I don't know where it is or what it is, but it's some method that returns a string. Any guesses as to what we would do to the email control here?
Let's ensure that it just use that symbol and not the comment.
Yeah, that's true. But really in email control, I don't need to define that there. That's what would have happened here, is it would have defined that specific string. But I want to get rid of this duplicate code entirely. And because email control inherits from text control, it has this ability right here to just define some value command method. And so what I can do in email control is just get rid of that code entirely. And if that's all the code I have, I may be able to get rid of this entire class. And how I would do what it is you're suggesting is, how do I actually ensure that an email is actually generated? I would do that on the page now. Well, first I would have a library of text generators. One of them is an email. So I kind of demote that code from here to here, or as I said, use some external package. And then in the page, I would define which method to use. So in this case, I'm using this helper class that I created that is guaranteed to generate an email address. And rather than defining an email control here, actually I don't know in the previous, initially this should have been email control, and then it would have been replaced with a text control, but passing in an email generator instead. And so, again, we're on a mission to exterminate any kind of duplicate code, yeah? How so? It could be, but maybe I want different emails for different purposes. I guess a better example might have been, different kinds of text controls might be first names and last names. So you might want different generators for that, or dates, and we're doing applications to college. So if you wanted to make a generic date control, depending on the page, you might want to pass in a different method depending on the context of that date control. So for example, date of birth, you want a date in the past, probably a date, for our genre anyway, between 17 and 22. But there might be a date that you intend to start college, so that would be a future date. So yeah, I guess I could kind of see where you're coming from. Ultimately, we want different types of generators in different contexts. And this is a way to do it without at least having a whole bunch of classes if the only difference is that set value. Yeah. Good question. Any other questions? So the fourth topic is using, in contrast to a delegate function, a delegate object to an existing system class. Before I say the context as to why we wanted to do this, I'll just review the pattern. So the pattern, also known as an event handler, used in kind of event-driven application design often, is, so we have this class over here, which is kind of our main worker class. Actually, it's easier to describe if I just go to the next slide. So we wanted to implement it in terms of API client to create integration tests. And .NET has a great HTTP client, but they also provide the ability to pass in an event handler into that client when you create it. And there's a whole bunch of methods, one of which is send async. So it's to actually send the request. And the problem that we had with the default send async method in .NET is that a whole bunch of stuff happened in that black box, and we wanted a way to very easily just gather a whole bunch of that data for analysis. So after a test is run, we could see what requests were sent and a variety of other things. So in our test, we instantiated the client to perform that work, but we used this constructor to pass in a handler. And what a handler will do, if it's defined over here, is when a method is called that the handler implements, the handler can execute that call, but it also has the context of the original object. So it has the context of its own, of itself, which is the handler, as well as the original object. And so in our tests, when we could create or construct the API requests, we call send async. That call is actually forwarded to our custom delegate object. There's a copy paster there. It should be class to delegate functions, class to delegate object. Anyway, so send async, instead of going over here to the default HTTP client, is forwarded over to our logging handler, which has a reference to base.sendAsync. So the base.sendAsync is not the base of this class, but again, because it's operating with this object's context, it's actually this sendAsync. And before and after we call sendAsync, we implemented our logging function. So as I said, we implement the route that was called and the payload and the response, and also we implemented a stopwatch timer before and after the send async happened, so we could kind of use our integration test suite as a mini performance test suite and see exactly how long our overnight regression tests were taking. I guess the other advantage too of this design pattern is, and this is a question I asked when our developers suggested that we do this, is why couldn't I just extend this class and then simply override that rather than creating this whole extra thing and putting the same code in there? And the issue came down to, I guess, inheritance. And you should only use inheritance when you want to develop a is-a relationship between two different objects. And so a logger is not really a type of HTTP client, because I could use this logging functionality in a whole bunch of other cases, as long as those other cases had a send async method. For example, 5 or so years ago, maybe a little bit longer, Microsoft actually didn't have HTTP client. They had something else that they deprecated. And so because we created this separate handler, instead of extending that class, we could reuse this code in theory at least. So it's about using the object-oriented design principles in ways that are effective, because we could have overrode HTTP client, but this was a better core pattern to utilize. Okay, a couple more. One is about abstract classes, and there was some reference to abstract classes earlier if you were looking closely in the page object model design, but we're going to apply abstract classes to a different context. And if you were having trouble understanding how, if you don't use UI testing, how some of the previous examples would apply to you, I think this one would apply to many situations, because the problem we had is about a year ago at this time, March through June, we developed a new application at our company, and over the course of those 3 months, we developed dozens of user stories and tons of functionality, but only for one single user role. And then in the course of the next 1 or 2 sprints, because of how development had architected their code, they were going to spin up 6 other user personas over that short period of time. And so we were left with, how are we going to regression test and keep up the pace with our development team? And it came down to, because we had invested in those 3 months creating a regression automated test suite, figuring out how we could effectively multiply those tests to run all of them for the different user roles. Some of which had different permissions, so there might be exceptions, but what we wanted to do in the cases where the functionality was the same across all user roles, leverage all those tests rather quickly. So we use abstract classes. And abstract classes is a type of class that may have code or may not have code. Or it could have both. So here this conceptual abstract class, there's one method that doesn't have any code and another method that does. And then the subclasses will inherit this stuff here. If it wanted to, it could override this, the stuff that's implemented. But it also must implement the unimplemented methods. And so this worked pretty well for this persona idea, where we said if all of our regression tests can be guaranteed at least within a single abstract class to start at the same spot, and that same spot was common for all user roles, then we just move all those test methods into abstract classes, and then subclass those abstract classes into one class for each persona. Because the only thing that will be different in the case I described is the setup method and how they navigate to that initial point of launch for the rest of the test method. And so user 1 will log in as an administrator. User 2 would log in as an applicant in our case, or some other end user that's maybe going to have more loopholes to jump through before it gets to that launching point for the rest of the test. And so in that way we have this one method here exists both in this class and in this class. And that's how we leverage abstract classes for different persona testing. And the last one was an interesting scenario where we had data that was kind of similar but not similar. The easier way to describe it rather than a bunch of words would be here. Basic OCAS is in as most companies in like a data business where we're transferring data between different partners. And one of the things we did is we had a NoSQL database here, which is full complete sets of data. And then our customers wanted just subsets of this data, depending on wherever they were in their business flow. And so then our web service transformed the data into actually an entirely different type format. They wanted it in XML for some reason instead of JSON, but that's fine. We can change data from XML to JSON. But the problem was there's only some of the data and only some of the time. So I'm speaking very generically here. And so the problem was, how do we determine if these two sets of data are equal or not equal? Because if we try to just serialize them all to a common component and compare them, it's going to fail because some of the data is missing here. So our developer suggested, why don't you use reflection properties of our development language? And many development languages have this ability. And reflection is the ability to, at runtime, for code to analyze itself. basically look at itself in the mirror, thus the name. So, you could find information about its assembly or various objects that exist at runtime and inspect the interfaces and fields and other classes of the code, again, while it's executing. And so, if we have a situation here where some of the data is here and other data is here, and we want to programmatically, rather than kind of brute force code a comparison method, we could just iterate through all the properties that exist here and only compare those ones. Whereas if we started over here and iterated over the properties, then we're going to get things that aren't equal. So again, this is somewhat pseudocode. This is not our actual code, but this is exactly where we use reflection. So we're saying, that our object is called SomeObject, and using the reflection classes of properties, we can get a list of all publicly available properties and get the value of the property of the object that was passed in. So we passed in this transformed object and also the source object. And so, even if there may be get or set methods for these properties, but we can just programmatically iterate through all of them by using the properties of the reflection framework within our development framework. So to recap, kind of the 6 concepts. I get, the overriding one is if you're writing test code, know some of your foundations. You should probably invest in developing coding, in developing your coding skills if you're not doing that already, or at minimum talk to your development teams. They're the experts. They develop code every day. Understand object-oriented principles and don't rely on just the ones that you know, like encapsulation. You can develop a page object framework similar to ours if you find value in that UI testing. Again, delegate functions, we generated random data using that. To eliminate duplicate code, we use a delegate pattern to add utilities to our framework where inheritance wasn't really the right design principle. Multiplied our tests for different user personas of abstract classes, and also just talked about reflection to compare equal but yet unequal data sets. Overall, though, these are not revolutionary ideas. All these ideas, I recognized that we had a problem at various points in our test framework, and just described the problem, and then within minutes, our developers said, "Oh, this is what you got to do." And so I took an hour to describe them, but this is really second nature, at least to our developers. They understand how to solve tough coding problems, and that's the best thing you can do when working with your development teams and developing your test frameworks, is to, just as you come to presentations like this to develop testing craft and get new ideas about testing, developers do the same with development, and you can do the same as well to understand good, solid foundations for coding. And we really, to do that effectively, close that last 200-foot gap or 10-foot gap, get in developers' faces and learn from them. They're the best sources of knowledge when it comes to development, and test development is development. So that's all I had for today. If there's any other questions, I can take them either now or later at the front here. Yeah?
In your test examples, you generate random data quite a lot.
Mm-hmm.
How do you make sure that when something fails, it is reproducible?
Right. Yeah, so the question was, when just generating random data rather than relying on a known data set, how do you know that, or how are you able to reproduce the failure when it fails? I think that comes down to partially logging of your test framework and building that in. So maybe in that set value method, injecting your logger into it and making sure that anything is logged when you're doing it. Also, we have, if we're doing UI tests, you could take a screenshot at the point of failure or at other various points. But I think logging is probably the easiest way to know exactly what happened when the test was running and to debug later. And we use these random methods more to get to the point, just to get the test as quickly as possible to the point where we actually want to do some sort of actual test. For the login page itself, we might have specific users that we want to test at specific times to test the different, whether it's different user permissions before or after login, or different types of characters in the email address. Right? We would still definitely do that and feed that into the test specifically. But it was just a case where you need to get through your test to the point, or to a particular point. You don't need to provide that specific information just to feed in random data. But you had a question?
I was just going to ask, how do you make sure that, using that, one time passes into the fruit?
Right.
Happens to avoid some
Mm-hmm. I mean, our tests are set up to run every single night, whether or not there's a change. So that's one way you could detect it. And actually, we found.
How do you know that
Yeah.
last night's one was actually covering it?
Right. Well, again, similar to this answer, we use those random methods more to get to the point where we actually want to do a real specific test. At that point, we would feed in the actual data that, for that feature or whatever. Like if we're doing a login test, we wouldn't run, the simple code that I mentioned. We would feed in specific login names or, test different password characters. Like we would use a data-driven test design for something like that. So we test all those permutations specifically. Yeah, and actually, though, having random data was pretty useful. We found cases where, because of that random data, we found bugs. Because it was entering data that, while random, was real enough, like a specific email address in a specific format. I guess one of the examples that I could say is, so we had an opportunity, or the applicant in one of our systems has the opportunity to provide 2 different email addresses. But only one of them is the one where you should actually get an email. And what our automated test discovered by entering, like sometimes it would enter the same email in both locations and other times it would enter a random one. And we found in cases where it entered a random one, email was not sent to the correct location. So, we use external libraries to generate different names. And, if you analyze the data after the test runs, you might find, even though the test passed, something doesn't look right, like a long name is cut off or something. Like investigating the results is, I think, how we mitigate some of those problems. Sorry, I can't hear.
What's it? Robert drop tape to students.
Yeah. Any other questions? Yeah.
Do you have any specific advice for the market?
I mean, for the longest time, we dumped everything in a text file. And then recently we discovered, we're using Microsoft Unit Test Framework for our assertions and such. And we discovered, within the test context, it has a logging utility. And so we, then built in the test context into our test framework. And then we logged everything to that. And then we run our tests on TFS Online or via Visual Studio Team Services Online. And then the logs just magically appeared there when we're using that. But yeah, whatever's easiest for you. Using our delegate handler pattern, we could easily change that at any given time if we wanted to. Yeah.
Did you find that it was easier or more efficient to come up with, to instantiate these concepts into the framework on inception?
Yes.
Or to get to a minimum viable product using the old methods, and then kind of work with developers afterwards to move that over to something more meaningful?
No, I answered yes when he gave me that option to do it from the inception. It's obviously much easier. When you're dealing with any kind of legacy code, whether it's test code or application code, it's much easier to build it in from the beginning. So, I built up, our test suite with the page object framework for one of our applications 3-4 years ago. So that application's kind of been slowly deprecated over time. It's not as important to us, so I'm not going to invest the time to redo it again. I know for sure it would be a big pain. We find every year we learn a little bit more and become a little bit better developers, and we just integrate new concepts where it makes sense. And retrofitting older test code is pretty hard.
And follow-up question to that: does that significantly impact the ability to get a minimal viable product up and running for a test framework? To start over with, to start with those concepts right at the beginning, especially for somebody who's not, again, like myself, who's a full-time developer. Yeah. That's something that would actually significantly impact my ability to deliver a minimal viable product.
Yeah, the old way with that for which you can find dozens or hundreds of courses that's definitely easier to quickly get up and running for sure. That's probably why those courses teach that. Yeah, to develop this, you really have to understand inheritance and abstraction and make sure you inherit and abstract the correct things in order to be effective that way. So maybe a year ago, about 15 months ago, we started on this design. And yeah, we took some iteration to get up and running effectively. But this year we started a brand new product. So again, we had the opportunity to do a clean slate, and we took all our learnings and we were up and running very quickly. So yeah, if you don't have a lot of the core development foundations, the traditional way is probably way easier to get up and running faster, but it's going to lead to longer term maintenance nightmares.
Thanks.
Yeah, you're welcome. Yeah.
It's just more on a non-technical side. How do you get your existing developers to get interest on helping you out for the negative test? Because we don't hire other developers for this.
Right.
They have their own jobs.
Yeah.
How do you get interest on that?
Yeah. So the question is, how do you get developers interested in writing and helping you with some of this stuff?
Yeah.
Yeah. I think we're lucky at our company. It's a small company. But even if you're at a large company, you often operate in a small team, or hopefully you do. And really how we pitch it to them is, you're not working on test code, you're working on code. Test development is development, right? And I think if you say this is kind of the framework problem that we have, how would you solve this as an application developer? At least our developers really like working on frameworks and developing code efficiently. And if you frame it to them that way, maybe they'll be more apt to take on that challenge. And at least help you get the framework up and running. Writing the actual tests, I agree, even at OCAS, they probably have less interest in that. But if you frame the problem to them that way, they might be more able to help you. Yeah.
Well, like you talked about, Selenium's been around for a long time,
Yeah.
but pages haven't changed in a long time. Some of this low-level basic stuff, or text boxes or drop-down boxes. Are you aware of any open source frameworks that have been developed that to comment on other people, get you up and running a little bit faster?
Yeah.
You have some basic
Yeah.
core stuff there.
I guess that would mitigate the question over
That's
here,
what I'm
right?
asking.
Yeah. I mean, I guess we kind of started thinking about that at OCAS. I guess we'd have to look into what our rules about publishing code externally would be at our company. But what we did for this most recent project, or what we're doing right now, that we're working on, where we're kind of, again, starting from a clean slate, as I said, is we developed some of those lower parts of the test framework that you mentioned that don't change regardless of the application. If it's an Angular application or a .NET or an MVC application, as a tester in the front end, it doesn't really change. So for our current test project, we started bundling that and publishing those pieces of our framework as NuGet packages on our own private NuGet feed. And we're seeing how that works. Maybe at some point we'll publish it to GitHub or something, but yeah, I'm not aware of anyone else that has done that. I didn't mention, but like a year ago, I had this topic, again, hoping not to be the follow-up to a NASA scientist. I researched Google, and like someone had to have thought of this before, right? And the closest I got was Page Factory, and as I said, that has tons of Selenium. It doesn't really solve the problem. And again, after NASA came in last month, I looked again, I'm like, okay, maybe I still have time to get out of this if I don't want to be this follow-up act. And again, I searched Google for like an hour trying to find in different search terms, has anyone else thought of a different way to do this? And at least no one has published it as far as I can tell. So no, sorry, I don't know of anything else that exists. But the slides I give them to Tina, will you post them on the website? At least it gives you a hint. It may not be totally compiled or compilable. I noticed some spelling mistakes even this morning that I corrected in the code part. But at least the concepts should be on the KWSQA website later. Yeah.
I have two questions.
Yeah, sure.
First, the selection pattern that is fine. Based on what I understood, it's like you have data, you have advanced information as well as mappings or you have in the code. So is it like you would, based on your test data, you figure out which method to call and basically you write it down?
It's not really based on the test data, it's based on the properties of the object,
Okay.
right? So, yeah, I can go back, because it was near the end. Oh, I shut this off. Right. Yeah, so you're talking about like this case right here? Yeah, so that's based on the entity contained within the object. It doesn't really matter what data is there. It's based on like if that's a string, or maybe that's a custom data type would be a better example. Whatever, some custom data type within our framework, if that custom data type is called some type, then do some other specific verification. Yes.
And on the delegate object,
Yep.
you really could do, because the class was designed in such a way that you can accept that.
Yeah.
So let's say we have one party property which you can't even change
Yeah.
the code, maybe that type of properties and fall back to the other patterns.
Pardon? The last
Fall
part?
back to maybe some other pattern to put it working.
Maybe, yeah. Or maybe your development team would have some other idea about how to inject a handler into that object.
Okay.
Yeah, if it was an external library that didn't have a handler by default, as in my case, the .NET HTTP client did. Yeah. You're welcome.
I guess we should wrap up.
If there's more questions, I can take them here.
Thanks very much.
All right. Oh no.